Okay, last skill in this particular achievement standard is using bearings and trig and measurement and all those things all together. So let's just recap bearings very briefly. So bearings are a directional thing where you start at north, so we know north's up here, and we measure all the way around with everything being cut in half. So this would be north, south, west and east. But when we use, that's a compass bearing, so a little bit of a difference. When we use a bearing, we only ever start at north and we go clockwise round. So we call this 0, 0, 0 because a bearing has 3 digits always. So if we go halfway here, it would be 0, 4, 5, 45 degrees, 90 degrees, 135, 180, 225, 270, 315, and back to 0, 0. So that's how bearings work. We always put lines that go pointing upwards when we start from our bearings. So let's have a look at a question. So let's say they've given us a diagram where it's a course for the swimming leg of a triathlon or something like that. And they're leaving from point A and going through point B, C and home, all right? And they have told us that the bearing from A to B is 110. They've told us the bearing from B to C is 290. All right. They've also measured 2 lengths. They've told us A to B is equal to 18 kilometres. I think that seems like maybe it's a bicycle race. And from B to C is 25 kilometres. And they want us to find the bearing. So the question is, what's the bearing from C to A? And how far is it from C to A? All right, so those are the 2 questions. Now, this is almost definitely going to be an excellence question. So what we need to do is start off with our diagram and put all the information we know on our diagram. Normally in the exam it will be on it in some form, but these parts might not be. So 18 here and 25 here. All right, so bearing A to B is 110. That means this angle here is 110 from north around to where you're swimming. B to C, 290. So from north around B to 290. Now what we use here is our knowledge that all of these right-angled ones, we know 90, 182 at 270. Also, we can sometimes use angles on parallel lines because our north tracks are always parallel lines. So what we're trying to find, lastly, is this length. I'm going to call it length, L, and the bearing from there to there. All right, then I'm going to call that B. I'm going to try and find B, and oh no, not a good letter. Let's call it D for direction. Okay, so I'm going to try and find L and D. Now, I'm going to give you a few hints here. The biggest hint I can give you is that what you need to do is make as many right-angled triangles as you can because that's the skills we've got. So we enclose our triangle within a rectangle that's nice and straight. So I'm going to go straight across here, down to here, straight across here, and back up again. That gives me 1, 2, 3 right-angled triangles. So I can use those to figure out everything I need to know. So I need to start by finding, what I need to find is that angle there and that length. So I need this length and this length. But if I go around this triangle with the things I know, I'm going to get there faster. So I know that this angle here is, that's 90. So I'm actually going to change that to 130. That's 40 degrees. All right? So I've now got a triangle that looks like this. 40 and 18. I want this length and this length. All right? So I'm just going to use trick. This one is opposite, so it's 18 sine 40. And this one is adjacent, so it's 18 cosine 40. So I've put those into my calculator. I get 11.57. I'm going to do this one to one decimal place because we're talking kilometres here. 18 cos 40. 13.78, so 13.8. So far I've got that this whole side here is 11.6 and this bit here is 13.8. All right. So I know that this side is 11.6 because it's a rectangle, and I know that this side, well, I don't know how long this side is. So now I need to go to the next triangle. So my next triangle is this one, and I've got, this is 270 to the red line, and 20 more. All right? And it's a right angle because I made it such, and this is 25. So again, I can find this length and this length, right? V is opposite, so V, this is going to be U is opposite and T, and this one is V is opposite, so it's 25 sine 20 degrees is V, and 25 cosine 20 degrees is W, all right? So I've got 25 sine 20. This one is 8.655, so I've rounded it up. 25 cosine 20 is 23.49, so rounding it up. So now what I know is that this length here is 23.5 and this length here is 8.6. All right, my diagram doesn't have to look good, all right? Just has to be right in the end of it. So actually it's not a very good diagram. Now, knowing all of that, I can actually find out in the triangle that I want, which is this one here, all right, the red one up the top, with D here and L here. I can find this length because I've got 11.6 on this side and 8.6 here. So 11.6 minus 8.6 equals 3 here. And I've got 23.5 minus 13.8 gives me 9.7. So 9.7 is here. So now I've got two sides. I can find L because I can use my Pythagoras. So L squared equals 3 squared plus 9.7 squared. So L equals 3 squared plus 9.7 squared equals square root, so equals 10.15, so I'm doing one decimal place. So the length, so I'm answering this question first, length from C to A is 10.2 kilometres, all right? Now I need to find the bearing, so the bearing is from north around to the track. So I just have to find this little angle in here. So I can use these two and go tan of D is equal to the opposite, 9.7 over 3. So D will equal inverse tan, bracket, 9.7 divided by 3, bracket, equals 72.8 degrees. So the bearing is, now we have to add that on to 270 because it's got to go right from, oh no we don't, it's just that much there, isn't it? So 073. Alright, so that's the angle, 073 because it's 3 digits. Okay, so I hope that helps you answer those sort of questions.